Welcome to the mole video. By the end of this video, you should be able to understand the meaning of the mole as a quantity, determine the number of particles in a sample when given the number of moles, and determine the number of moles in a sample when given the number of particles. Let's start with the mole as a concept. A mole is simply a quantity, just like a dozen is a quantity. A dozen is 12 of anything. So if you order a dozen donuts, you'll get 12 donuts. If you order a dozen bagels, you'll get 12 bagels. A mole is the SI unit for measuring a quantity. It's just a really big quantity. So a dozen is relatively small, equaling 12. A mole is this many of anything. Obviously, that's a really annoying number to write, so we usually represent it in scientific notation as 6.02 times 10 to the 23rd. This is often referred to as Avogadro's number. Before we start doing calculations, let's talk a little bit about vocabulary. Recall that we use the word particle to describe atoms or molecules. You'll hear particle in a lot of the questions in this video. If we're talking about a substance made of more than one atom, then particle refers to molecules. So if we're talking about particles of water, we're referring to water molecules. If we're talking about an element, then particle refers to atoms. So if we're talking about how much carbon is in a sample, we're talking about atoms of carbon. We're going to start by learning how to convert from moles to number of particles. This question reads, I have 3.2 moles of zinc. How many particles do I have? We're going to solve all the problems in this video using a proportion. So, since I'm given moles of zinc and asked for atoms of zinc, notice here this is an element, so particles are atoms, we're going to set up a proportion between moles and atoms. The first half of my proportion is always going to be the relationship I know. So it's the relationship between moles and atoms, which I know to be 1 mole of zinc equals 6.02 times 10 to the 23rd atoms of zinc. Because again, 1 mole of anything is 6.02 times 10 to the 23rd of that thing. I'm going to set this equal to the information from the problem. 3.2 moles of zinc is equal to X atoms of zinc. I like to read this to myself as a sentence. So basically this proportion to me says that 1 mole of zinc equals 6.02 times 10 to the 23rd atoms of zinc. Therefore, 3.2 moles of zinc must equal X atoms of zinc. From here, I cross multiply and I solve for X to find that 3.2 moles of zinc equals 1.9 times 10 to the 24th atoms of zinc. Does this answer make sense? Well, 3.2 is more than 1, so our answer should be more than 6.02 times 10 to the 23rd, and it is. It's always good to just kind of common sense check your answers when you're done. Let's review the structure of this setup because we're going to be using this same structure over and over again. As we said, half of the proportion is the relationship that you know. In this case, the relationship between moles and atoms. The other half of the proportion is going to come from the problem. It's also important to make sure that you've lined up your units across the problem. Moles should be across from moles and atoms should be across from atoms. I could have done this whole thing upside down and put atoms on top and moles on the bottom, as long as the units line up across the problem. Now we're going to look at how to do the reverse, convert number of particles to moles. This question reads, 1.76 times 10 to the 34th particles of water is equal to how many moles? Here we're looking at water, which is a molecule, so particles refers to molecules. So we're given molecules of water, and we're asked for moles of water. So half of our proportion is the relationship we know between moles and molecules. 1.0 moles of water is 6.02 times 10 to the 23rd molecules of water, because 1 mole of anything is 6.02 times 10 to the 23rd of anything. We'll set this equal to the information from the problem, X moles over 1.76 times 10 to the 25th molecules of water. So again, as a sentence, this reads, if 1 mole of water equals 6.02 times 10 to the 23rd molecules of water, then X moles of water equals 1.76 times 10 to the 25th molecules of water. Cross multiply, solve for X, and we find that 1.76 times 10 to the 25th molecules equals 29.2 moles of water. Again, does this make sense? Well, 1.76 times 10 to the 25th is larger than Avogadro's number, so our answer should be more than 1, and it is. Again, this half of the proportion is the relationship we know, and this half comes from the problem. And our units line up properly. Here's 2 practice problems to try on your own. Pause the video here and try these. When you come back, I'll reveal the answer. Welcome back. Here's the solutions for these 2 problems. Now let's consider how many atoms are in a mole of a given compound. First, consider if we're talking about a mole of people, for example. This would be 6.02 times 10 to the 23rd people, because 1 mole of anything is 6.02 times 10 to the 23rd of that thing. Now consider how many heads are in a mole of people. Well, presumably each person has 1 head, so a mole of people is equal to 1 mole of heads, or 6.02 times 10 to the 23rd heads. What about hands? How many hands are in a mole of people? Well, if each person has 2 hands, then a mole of people would contain 2 moles of hands, or 2 times 6.02 times 10 to the 23rd hands. How about toes? Assuming each person has 10 toes, a mole of people would contain 10 moles of toes, or 10 times 6.02 times 10 to the 23rd toes. This same concept applies to molecules. Take a CH4 molecule, for instance. A single CH4 molecule contains 1 carbon atom and 4 hydrogen atoms. If I have 10 CH4 molecules, I have 10 carbon atoms and 40 hydrogen atoms. If I have a mole of CH4 molecules, I have 1 mole of carbon atoms and 4 moles of hydrogen atoms, or 6.02 times 10 to the 23rd carbon atoms and 4 times 6.02 times 10 to the 23rd hydrogen atoms. Let's look at this in the context of a problem. This question reads, how many molecules are in a 1.5 mole sample of CH3OH, and how many atoms are in this sample? Notice the first half of this problem is what we've been doing all along, so I'm going to go through this kind of quickly. First, we have the relationship we know between moles and molecules. We're going to set that equal to the relationship from the problem between moles and molecules. Cross multiply, solve for x, and I find that 1.5 moles of CH3OH contains 9.03 times 10 to the 23rd molecules of CH3OH. But I want to know how many atoms there are in this sample. Let's consider a single molecule of CH3OH. Each molecule of CH3OH contains 1 carbon, 4 hydrogens, and 1 oxygen, for a total of 6 atoms. So again, we can set up a proportion. The first half of our proportion is the relationship we know, 6 atoms for every 1 molecule of CH3OH. We'll set this equal to the information from the problem, so we want to know how many atoms are in 9.03 times 10 to the 23rd molecules of CH3OH. Cross multiply, solve for x, and we find that that many molecules of CH3OH contains 5.42 times 10 to the 24th atoms. That brings us to the end of this video. Let's review our goals. First, we looked at the meaning of the mole as a quantity. Then we determined the number of particles in a sample when given the number of moles. And then we determined the number of moles in a sample when given the number of particles.